So next we have Wouter de Vries from Cloudflare, and he's going to look at another thing about authoritative zones, but it's real-life TLD authoritative performance based on Cloudflare experience of needing to query those zones. Thank you, Wouter.
Thank you. Yeah, so the title, I'll look at authoritative name server performance of TLDs. I'm Wouter de Vries, a systems engineer at Cloudflare in the authoritative DNS team for the past a little over 3 years. Sometimes I have nightmares about 99 percentile latencies. So why look at the TLDs? They're less studied than the root. When I was in university still, I was looking at these papers about the root name servers, and the thing I learned from that is that the root is pretty good and pretty fast, and we don't have to look at it all that much anymore. And, I'll be around if you want to fight me on that later. Also, I think it has a higher impact on the end user quality of experience, right? So because there are so many TLDs, like 1,500, and each having their own potential performance characteristics, I thought it was quite interesting to have at least a little bit more of an in-depth look at it, and it's a kind of a hobby project of mine within the company. I think I have the same slide twice. Maybe you're here and you don't know what the DNS is. Very quickly, there's a resolver involved usually, and then there's a root. There's the authoritative for the TLD, and then usually another authoritative for the domain itself, and then you can go ad infinity down this stack if you want to. And we'll be looking at the middle one here. So latency is less important for the root because you only query it very frequently. The TTLs are very long usually. If you look at .com, I think it's something in the region of 24 to 48 hours. So in theory, you only have to do like one lookup every 48 hours to that. So it's super easy to keep in the cache. Although I don't think we ever keep it this long in the cache since, I don't know, computers have their own way of doing things. So when do we, as Cloudflare, query authoritative name servers if we're not talking about the public resolver? As some of you may know, we have a CDN, and in that CDN you can configure an origin, and that origin can be in the form of a CNAME. And in fact, quite frequently it is in the form of a CNAME. So basically we get a query from our internal web server, like the CDN thing, and we'll say, oh, what's the origin for this customer, for this domain name? We'll do a lookup in our database, and it comes back as a CNAME, and then with that CNAME in hand, we have to go to the internet and ask what it resolves to. We use DNS-dist for that as a first layer, and DNS-dist will upstream to a number of unbound instances that run in the same facility that this query is being handled in. You may say, well, hey, Wouter, don't you run your own public resolver? Why are you using unbound? That is a valid question. But this setup predates the launch of the public resolver. So it's like a work in progress to move this over to the public resolver. But currently, this is the situation that we have. And unbound is performing reasonably well for us, for which we are thankful to our NL Labs colleagues. Yeah, so there's another moment when we do this. It's when we have CNAME flattening enabled. So there's a way that you can say, if you don't use our CDN, but you do use the DNS, then you can basically just use us for DNS only and not proxy any traffic through us. And then you can put a toggle on a record on a CNAME and say flattening. And then instead of returning the CNAME to resolvers, we will return the IP addresses that that CNAME resolves to. So that's the other way. And then the rest is exactly the same. We have DNS-dist upstreaming to unbound. So how do we collect this data? We use DNS-tab, which is a bit of an obscure format. Well, obscure, it's widely used, but it's kind of not very well documented, but we use it here. So unbound can emit, and I think every reasonable authoritative DNS implementation can emit DNS-tab logs, which is basically a log format that it has like, if the query comes into the resolver, it has like a special tag for that, and if it goes out for a particular reason, it has another tag for that. So you can like identify all the types of different queries that a resolver can potentially do, and for the stub resolver, and for the forwarding, and for the recursive. So it has all kinds of different things to make the logs kind of to differentiate between the different resolver types that there are, and also for the authoritative side it's possible. Then on every server we have this DNS-tab bridge, because the DNS-tab is in protobuf, And the locking forwarding system that we have is in Captain Proto. So we convert it on that surface, then we go to log forwarder, we log forward it to a core facility where it's received, written to Kafka, read again by an inserter, and the inserter writes it into ClickHouse. And ClickHouse was discussed earlier here today for DNS-OARC data research purposes as well. And we also have very good experience, and also some less good experience sometimes with ClickHouse. The nice thing that ClickHouse has that I don't think was mentioned before is that you can have like this concept of an aggregating merge tree, which basically means you can make like it's like a materialized view. So you write this query with a bunch of group bys. You can see here the columns I used as a group by. So there's a time slot with a 1 hour granularity, like the TLD, some data center or colo, as we call them internally. Like the name server name, IP addresses. And then you can say, okay, I want to know, I want to keep some metrics on that. And in this case, I also keep I pull the root, from the root I pull the zone, and I store all the TLDs and the IP addresses in a dictionary in ClickHouse, which is another ClickHouse concept. And basically taking an L and an IP address, I can then translate that to, oh, that's ns3.ns.nl, and I know I have to store this in this table. So we keep the query counts, the response time quantiles in all kinds of different formats, like 0.25, 0.5, the median, and 99, 999, like that. And we currently have 5. We've been collecting it since the 6th of March 2023, so pretty more than a year. And it's like 5 terabytes of data covering 2.6 trillion queries. So it's a really nice way to, like, if you already know what you're going to be looking for in the future, which is a big caveat, then you can like save a lot of storage by doing it this way, and you can still cover a lot of data. Because these queries on the right, they're basically instantaneous. Also for if you want to do like a Grafana of this, it's also that also works very well. So we do approximately, these numbers are not huge. We do 3.5 billion queries to TLD authoritative name servers per day, and 40,000 queries per second roughly, which compared to like the query volumes that we regularly get is a pretty small number. But still, I think it's quite sufficient to at least have a look at the performance. And roughly half of those are going to the .com name servers. So the .com and also the .net latency, because they share the same name servers, they are very, very fast. Median 7 milliseconds across all our colos across the world. Still, the 99th percentile, and this is the thing I've been having nightmares over, is still 183 milliseconds. I don't know, 99 percentiles never want to get low. And customers also don't like that, I have to say. This is not a problem of the .com or the .net name servers. The 99 percentile is just a very difficult metric to get low. The B GTLD server, that's just one of the name servers that .com and .net has. The B one is the fastest of all of them. It has a 2.34 millisecond median response time, and somehow it's almost, well, I'm not going to say 3 times, almost 3 times as slow over IPv6. Here are some examples of slow TLDs. Some of them are not well known, but some, like for example, .ml, with the recent craze, for example, in machine learning. Some people think, oh well, I'll pick .ml, and they don't realize the performance hit they're taking just by picking this fancy name, right? .cf, it was a personal favorite within Cloudflare. Also not such a good idea, right? Even the median is almost 100 milliseconds. If you talk to them, the P99 is all the way out there. And this table only includes TLDs that we've at least sent like 1 million queries to in a day to get a little bit of a reasonable number. This is just a few of one day, but I've seen over time it doesn't vary that much. This is the .kr, the slowest one that we've seen. And you have here the global numbers, and then in South Korea, and then here in Czechia. And it's you can see that in South Korea actually, it's pretty fast, except one. And globally, it's not looking that great. In the Czech Republic here, there's only one server actually that's fast, and that's important to think about later when we consider how you should set up authoritative name servers. On the other hand, we have .pl, for example, which is 1 millisecond on the P50. And the P99 is also still pretty high. As I said, it's hard to get P99s low. So basically it means that wherever we have a facility, apparently also they have a facility. But also it means something else. If we look at the performance in nameserver, for example, which is in the lower right corner, you can see that they're actually not doing that great. But because their eyeballs, so the people who are looking for them, are located where their servers are, they're still fast as viewed globally, because we only do queries where people are asking for them. So that kind of influences how this statistic looks, right? Because we're not sending equal queries in every facility. We're only doing it where people are asking for them. And so the global stat is heavily influenced by where the users are. And so you don't need a billion servers to be fast. You just need to have the servers in the right locations. Just for fun, .cz, pretty good, median 16 milliseconds, 99% are also not that bad. Somehow slightly faster in Seattle than in Prague, which is, to me is kind of, I mean, you can't do anything with that information, but it is kind of interesting. And they also have like a bunch of different ones, and all of them are in general pretty fast, and that's also something I would recommend. I would never recommend someone to have like 4 name servers and then have one super slow one, because that super slow one is going to be your P99. There's also IPv6 and IPv4 look kind of similar, which is good. Talking about the current IP version versus the legacy IP version, almost all TLDs support IPv6. 1457, this was when the slide was made, I don't recall exactly when. 1457 had IPv6, and only 24 had no. I've put per continent there the latencies and across also the IP versions. There's sometimes some slowness in IPv6 that can be seen, unfortunately, but hopefully we'll drive that down. So how many IPs do you actually need? The range is between 0 IP addresses and 13 IP addresses. So for example, the comment.net, they have 13 IPv4 addresses and 13 IPv6 addresses. I don't know why they chose this specific number. Then you have their counterparts, basically, they have 2 IPv4 addresses, that's the lowest number, and then 0 IPv6 addresses. Interestingly, doesn't matter too much for the performance. You would say more IPs, it's more better? No, it's not the case. In terms of latency, if you look at .nl, .nl is a personal favorite of mine because I'm from the Netherlands. And they do apparently a good job with their TLD. They have 3 IPv4 addresses and 3 IPv6 addresses. And the median latency for both is like 4 milliseconds and 7 milliseconds, which is slightly better than the .NET, what .NET is doing, right? There has been a presentation from the .NET TLD about how they set up, like how you should like set up your authoritative name servers according to them. And there they also mentioned that having only 1 or 2, like having a super fast Anycast network and then putting 1 IP on that, then having another server, another IP address that is on a slower network for example, resiliency, will negatively impact your performance. And if you have like we just have this one server still, let's just put it in there for I don't know, some added resilience. I still have this desktop under my desk, so I can still use it. That may be very bad because resolvers, at least for example Unbound, but I think all of the resolvers kind of do this, they will always keep sending queries, even if they know the others are faster, they will keep sending some number of queries to this slower server, and it will impact like the P99, P99.9, and maybe even P90. You may think, why do you obsess so much about this P99? But we have customers that are obsessed with P99s, and that's why I am also obsessed with P99s. So there's no clear correlation between this number of IPs and the performance. We did a little, we had launched like a new offering recently, the Foundation DNS, and one of the neat ideas we had was like, oh well, we'll put for resiliency, we put the 3 same IPs under 3 different name server names, because all our IPs are Anycast anyway, and there's no real difference. And that way, whenever one of the TLDs go down, we still have the same Like someone will still be able to get those IP addresses, which seemed like a reasonable idea, except there are some registries, such as .de, for example, that think that if you have two IP addresses that are slightly different, like 0.22 and 0.23, that is necessarily better than having 3 different name servers with the same IP addresses. Right, so just saying that because hopefully we can someday get rid of that idea, or maybe it's very good to have that limitation. But to me, it didn't make a lot of sense to have more IP addresses just because we want to have more IP addresses. That doesn't make a lot of sense to me. So yeah, Anycast potentially hides a very large network behind a single IP address. I remember the days when I was starting with like looking into web hosting and stuff when I was young. I'm still kind of young, but then the idea was you hired a dedicated server somewhere, and you had this requirement of 2 IP addresses. So you'd ask your dedicated server provider to give you 2 IP addresses on the same machine, and so you met this requirement, right? So one thing to consider is that especially for ccTLDs, is to consider where your users are. And obviously it's very easy because sometimes your users are in the country that the ccTLD is for, like .nl will likely be most used in the Netherlands. .tk maybe, I don't know, it may be used in different countries than the island, right? So it's as an operator, you should consider where you are and where your users are. And of course, if you just have a lot of money or you don't have a lot of money, you also have to make different considerations. If you add 100 milliseconds of latency before you've even started doing anything, like DNS is usually one of the first things, that's going to be noticeable. Maybe not by the end users, but by your customers maybe. Like if you add once 100 milliseconds, that's one thing. But like every step, like there's so many steps today and so many domains involved. If you open a random website and you look at how many connections are being made to how many different domains, that's all adding up together. So just adding these milliseconds somewhere can be really impactful, more impactful than you initially think. Same for the TLD operators, basically what I just said. Just adding more IPs doesn't necessarily improve performance, and it may may hurt performance. Yeah, I've gotten to the end. If anyone has any questions, I imagine that I will also be around all the way until the end of Vries, so you can catch me whenever you want.
Jacob Zach, Sierra.
Yeah.
.ca, a Cloudflare certified fast TLD.
Nice.
T-shirts are being printed. A couple random comments. So looking at our Anycast clouds that we operate, we have a mix of things we operate and third parties. We see about 80,000 packets per second or so coming from Cloudflare. I would imagine that our success is largely dedicated to our pairing at mutual internet exchanges pretty much everywhere in every region. I think the variations in speed are largely due to where a TLD is in its evolution, I guess. Mm-hmm. You have the unicast phase, the internal domestic Anycast phase, we run our own Anycast, but now we have third-party Anycasts and all of those things. Not surprising to see Iran on that list, given that they don't have a lot of international partners, and most of their traffic is run through Europe anyways, right. Things along those lines. Some of the bigger mistakes I see in studying Anycast of TLD competitors and or partners, aside from not pairing at internet exchanges. There was in the ccTLD community very common to see, server trading. Your country will host a server for us, we'll host a server for you. If that's not done in a well-planned way, all of a sudden you're attracting all of Cogent to Papua New Guinea, yeah, or something along those lines. So I've seen that a lot. And I think the next thing on the horizon in that regard that I see happening now is server rentals, where there's an Anycast cloud, and they decide, well, we're going to augment our dots on the map with these server rentals where we don't really run the network, we don't have control over who's pairing with what. It's not super thought out. So all of a sudden you've added 4 dots to the map, but your latency has actually gone up. You didn't improve anything. There are many organizations, some of them in the Europe region that are 25 years in the making, 50 sites in Europe, and they're still leaking 20% of their traffic to North America and 20% of their North American traffic to Europe, just because of that lack of planning when it comes to transit providers. So those are my comments, your thoughts?
I mean, Anycast is definitely, if you don't have a big operations department in your TLD, then I wouldn't recommend, I think, running. If you try to run your own massive Anycast network, that's, as you said, it's fraught with danger. You spin up one side and it takes everything else down. Thanks.
Thank you.
Thanks. Hi, Dave Knight, Ultra DNS.
Hi.
I have a comment and a question. Here's the question first. So maybe I missed it, but did you look at what proportion of queries are going to your P99 rather than the P1s? Like, if somebody has 6 name servers, are you actually sending 1/6 of the queries to the slow one?
So the P99 by definition, I think, is like the top 1% of queries, like the slowest 1%. So it's 1%. But I mean, I'm kind of obsessed with the P99 just because that's where always all the questions are.
Right.
Like, it's always super nice, except at this 1 second, it's super bad, and that's what the questions are coming for. So no, I didn't really look at that. Yeah.
And the comment is that for us at Ultra DNS, we typically a domain gets 6 name servers ish, and but we deliberately taint the routing to those so that from any one point in the topology, at least 1 or 2 of those are going to be a bit further away than they need to be, just for resiliency's sake, so that if that one pop closest to you, it's not now a black hole for all 6 of the name servers. So that's why you're always going to see 1 or 2 of our name servers for any domain are always going to look slow.
Yeah.
But we think that's a reasonable trade-off for that.
Yeah, so we've got some comments from some people online. I got 3 of them here. The first one is from Greg Chulis. Do you have any numbers for .ai?
I have numbers, I think, for every TLD, but I like not off the top of my head.
Come on, man. Next question, Ralph Raber. With regards to differences between IPv4 and IP version 6, did you check if they were differently routed, or if it was just a difference in processing more bits, like more difference were...
I think it's like the IPv6 internet and IPv4 internet are basically 2 different things. Like, and the routing is completely separate. So they can be, I think that's what the reason is, that it's just, we're focused more on optimizing IPv4 routing, sorry, and IPv6 is,
So processing.
Yeah, I think it's as simple as that,
All right, and the last question was from Ben Schwartz. If you had an unbound option to not use the slow name servers except via background probes, would you use it?
I think we would. Yeah, I've had this wild idea about like making a map of the world with every name server in it, and just like know at any time, just have like an oracle that says this name server is the fastest, and never use any other. Yeah, work in progress. Yeah.
Right, thank you.
Hello, Tamás PCH. So I was kind of confused about how you were doing the measuring. So were you actually looking just how the TLDs respond, or you were going through all the chain like as you were doing the CNAME flattening thing?
No, it's strictly like it's we like if you have unbound, we look at the right side of that, and only queries that go specifically
to the TLD.
That's what's counted. So only like if its IP address actually belongs to like some TLD, that's when we count it.
Mm-hmm.
Yeah, so it's not the entire chain.
Okay, then I think it's in this case it's maybe more like the preference of the better answering servers, because if someone has better answering servers, then basically the reservoir should prefer that.
But at least we see that very often, and actually almost in all cases, the resolver will still sometimes prefer this slower server, which is annoying.
Okay.
Yeah.
Thanks.
Raffaele Junior Siltwente. Have you tried to check if, in case where you have like slow TLDs, it's because there is no POP in your region?
I mean, our region is like we have POPs everywhere.
Yeah, I know. So the reason behind why you have like...
No, I haven't looked like in specific cases, like why is this particular person slow? I have thought like maybe with using this data, I can at least see if the name servers are anycast or not. Like if you have like a speed of light violation in your response times, then you can pretty easily see if it's anycast or not.
You can even try to geolocate them, maybe.
Then you can quite easily at least see if that's the case. But other than that, no, I haven't looked at it.
Okay, thanks.
I actually have a question. The question is, when you mentioned that sometimes it seems that you're preferring slow servers or slow servers are being preferred, is that consistent and persistent, or is it in spates?
Like we know why it is, because actually, for in the case of Unbound, even if you set this fast server percentile or something, that's what the option is called, and it just says, okay, like for 99% of the queries, send it to the fastest 2 servers, but also sometimes send queries to the slower servers to kind of verify that they're still slow, which, I don't know, it feels like they won't change speed that quickly, so we may get away with doing that less regularly. But yeah, that's kind of, I think that's kind of what the industry standard is, to just query it fairly frequently. Yeah.
So I do know how Bind does it if anybody wants to ask me afterwards.
Well, it's always a balance, right? You can always send the query to all of the servers at the same time and pick the fastest one. But I mean, it's about the balance between the two. And I would really like to hear your thoughts, possibly in the hallway, what algorithm you would like to see, because this is like constant source of like tension in the resolver development community. I mean, what do we do? This or that? And, you know, conflicting requirements. So, I mean, the more information we get from the operators, the better.
I realized that
Are you about to ask the very same question? Can we talk about it?
Yeah, no, yeah, yes and no. No, there are different trade-offs. 5 years ago, I gave an IEPG presentation about how things work. DNS, kind of probing the name servers.
Right.
It's never documented. It's not. There's no RFC.
Right.
And I looked at the different implementation bind ours, and we all have different strategies. We are kind of very benign, so we're not very aggressively probing and retrying. But yeah, I do hear all kind of interesting ideas. So Ben Schwartz gave maybe an interesting idea.
Yeah.
And there are options to not so much probe the slow name servers.
Yeah, I realized I gave this talk very much with my latency cap on,
Yeah.
and not so much with like your throughput is also important. Like if you send everything to a single server, that's another consideration, which I did not focus on in this.
But there are all kind of strategies to get kind of feel what the status of the name servers. Sorry,
I guess we're out of time.
I'm going to have to wind this up now.